Assalamualaikum warahmatullahi wabarakatuh and very good morning. I greet to my fellow panels. Today, my name is Muhammad Razak Mahdi and I'm going to present to you about my final year project which entitled with optimization and validation of a headspace solid phase microsection gas chromatograph mass spectrometry method using central chemical design for determination of polyaromatic hydrocarbons in water samples. So I have outlined the introduction, literature review, methodology, results and discussion, and conclusion and recommendation, and also the references of my study. So the background of my study is I have studied about the polyaromatic hydrocarbons, the response surface methodology (RSM), and the headspace solid phase microsection, which is Hs-Spme. I have stated in my problem statement is that the continuation of polycyclic aromatic hydrocarbons, which is PAH, is a major environmental health and hazard. Thus, an optimized technique need to be used in order to have the greatest concentration of PAH analyzed. Thus, in this study, is to optimize and validate the implementation of Hs-Spme coupled with GC-Ms in order to study PAH. The PAH that I will be using is the target analytes of PAH, which is phenanthrene and fluorine in water samples. This method of Hs-Spme is considered eco-friendly, simple, rapid, accurate, and precise, and more sensitive analysis. The objective is to study is to optimize the Hs-Spme, which coupled with GC-Ms using RSM, response surface methodology, and CCD, central chemical design, for the analysis of selected PAH in water samples, and also to validate the optimized condition using other samples such as drinking water. And then, in my literature review, I have provided the structural chemical properties of my targeted PAH, which is fluorine and phenanthrene, and also what is the source of PAH. Source of PAH can be from oil, from fuels, from coals, and from the combustion of these things, such as in the picture here, the smoke that produces from car is the source of PAH, which will spread to the atmosphere. So according to KB 2019, it is can be said that there are tons of PAH that is found in this water samples. Here you can see the graph in which shows the accession time and the peak area of the series of PAH. And then my sample preparation is Hs-Spme, which is a new technology which combines pre-concentration and sampling process into the single step. This is very convenient, cost-effective, and quick. Also, in my response surface technology, which I will be using CCD as my design, which CCD optimize the interaction between two factors. And then this is my methodology. In the image, it shows the step-by-step procedure of undergoing extraction, which in my case is water samples. So firstly, pierce the sample septum and then expose the fiber and then retract the fiber, and then we inject the fiber into the injection port of GC. So our condition is 50 degrees Celsius to 95 degrees Celsius and extraction time of 10 minutes to 25 minutes. So in the right part of this slide is the condition of the GC, which conclude injector temperature, detector temperature, carrier gas flow rate, and column temperature. So this is my results and discussion. And this chromatogram shows the detection time of fluorine and phenanthrene. And fluorine having 8.870 minutes of detection time, phenanthrene having 10.0 to 6 minutes of detection time. So this is my regression model of ANOVA, which having a degree of freedom of 5 and F value of 13.31 and P value of 0.018, which all these values conclude that my model is significant. And also, not to forget the lack of fit, which is not significant, which shows that my model is fit. And then we go to the central composite design, which have generated a series of 13 experiments, which focus on the interaction between two factors, which is extraction temperature and extraction time. And then, so this is my summary of ANOVA, which I don't use any transform, and the model quality is significant. The lack of it is not significant. the R squared is 0.9048, and the equation of my total bit error is this. And then here is the predicted vs actual plot. So as you can see, the points are accumulated at around the diagonal line. Does this mean the model is good? And then in RSM counterplot, indicates and estimate the optimal condition between the two factors, which in my case, at the red part of the plot is that 16.69 minutes of accession time and 70.43 degrees Celsius of accession temperature. So after optimization, I have undergone method validation by using drinking water samples. So this is the result I have obtained, which is the unitary range for both analytes, which is 2.0 to 10.0 milligram per liter, with the coefficient determination of R squared of 0.994 and 0.993 respectively, LOD of 0.287 and 0.99, and LOQ 0.958 and 1.049 respectively. And then I have undergone recovery by using two concentration for both analyte, which is 5 milligram per liter and 7 milligram per liter. For fluorine, the average relative recovery is 60% and RSD is 0.31%. For phenanthrene, the average relative recovery is 101% and RSD 0.67%. And then for 7 milligram per liter, the average relative recovery is 103% and RSD 0.33%. For phenanthrene, 99% and 0.36% respectively. And then for the conclusion, the Hs-Spme-Gc-Ms can be optimized by setting up the accession time, accession temperature by using response surface method. And it is found that the optimal condition in analyzing the PAH is by 16.69 minutes of accession time and 70.43 minutes accession time or accession temperature. And also the method approved that it is applied successfully with the relative recovery of more than 60%. So my suggestion for future research is that the pH of the accession can also be used as manipulated variable and undergo optimization with 3 parameters. Will be needing a BBD, which is Bose-Baskin design, instead of using CCD, which only uses interaction between two factors. So this is my references. That's all from me. Thank you.